Hello everyone, welcome all of you in your science class. This is the part 3 of the ongoing chapter Motion and Time. I hope you have already watched the previous two videos. If not, then my request is to please go through that videos, then you can understand this class more easily. Now this class is going to be very important for you because in this class we are going to discuss about graphical representation of motion. Now this graphical representation is not only included in your class, it is also present in the higher classes like class 11, 12 and 9, 10 and so on. So watch the video very carefully. So our chapter is motion and time. In the first class, that means the first video, we have discussed what is motion, and in that video we have discussed if an object is moving from one position to another position, that is called motion. Now motion may be two types. One is called uniform motion, and another one is called non-uniform motion. Now the question is which one is called uniform and which one is called non-uniform. Now uniform means constant speed. Now when an object is moving with a constant speed, that is called uniform motion. Another way we can say, if an object is moving and if it covers equal distances in equal time interval, then also it is called uniform motion. For an example, suppose this is a car, which is car A. The car moves a distance. Okay. Now if we think that the car moves, first second the car moves 5 meter. So total distance is 5 meter. Next second the car moves again 5 meter. That means total distance is 10 meter. Next second the car moves again 5 meter. So total distance become 15 meter. Now like that way, each second car move 5 meter. So in this case we can say that the car moves equal distances, that means 5 meter, in equal time interval, that means 1 second. That is called uniform motion. So whenever a object is moving, whenever a object covers equal distance in equal time interval and maintaining constant speed, we can say the motion is uniform motion. And what is non-uniform? Obviously opposite of uniform. That means when an object moving with variable speed, that is called non-uniform motion. So for an example, suppose this is a car. This is first second, third, fourth seconds. So first, second, third, fourth seconds. Suppose in first second the car move 5 meter. Next second the car moves 10 meter. Next second the car moves 20 meter. And next second the car moves 50 meter. So see, for first second the car moves 5 meter. The next second the car moves 10 meter. That means total distance here become 15. 10 plus 5 is 15. Here 15 plus 20, that become 35. And here 35 plus 50, that becomes 85 meter. So gradually the speed increasing from 5, 10, 20, 50 means speed is increasing. So this is not a uniform motion. So that is called non-uniform motion. So I hope you understand what is uniform and what is non-uniform motion. Now students, we are going to discuss about the distance time graph for uniform motion. So whenever an object is moving uniform motion, we have seen that the distance covered is same as time interval, so we can say that the distance is directly proportional to time. The distance is directly proportional with time. That means if time increases, like same way distance is also increases. So if something is proportional with another, then the graph becomes straight line. Then the graph become straight line, passing, maybe passing through the origin or not, but the graph becomes straight line. So this is the graph of uniform motion. So this is a graph where a car or any object is moving with a uniform motion. So we have seen that for uniform motion, the graph of distance time, that is straight line. Let's see the next graph. This is also uniform motion, but here you can see two straight line, indicating that there are two cars, one having one speed and another one having another speed. So there are two cars which is moving. So yellow one indicating the car number A, and the red straight line indicating the motion of B. So these two graphs we can draw in a single graph paper. Here you can see single graph paper is there, and we have drawn two graphs. So we can compare both of the motion of the car. Now students, see, one graph, that means one straight line, is steeper than another. This indicates the steepness, or the slope indicates the speed of the car. So here you can see, just a second. So this is the slope of the car. This is the slope of the car, and it is more steeper. For the yellow case, it is more steeper. So it indicates that the car A having higher speed. The speed is high. So yellow car having higher speed, and the red car having low speed, because the slope of the red straight line is very low comparable to the yellow one. So we can say the speed of the car B is less than car A. So the steepness or the slope indicates the speed of the car. Now this is the non-uniform motion. This is the distance time graph of a non-uniform motion. So here you can see the graph is not a straight line. Here the graph is curved. So curved line indicates that the object is moving with a non-uniform motion. The curve here you can see it is look like that. So the the graph can be look like that also. So it is also not a straight line. So we can see that if the graph is not a straight line, the motion is non-uniform motion. The motion we can say that is non-uniform motion. Now here you can see this is the distance time graph of a stationary object. Now when an object is stationary, that means the object is at rest position, it is not moving, then the graph is parallel to the time axis. The graph is parallel to the time axis. Now whenever the graph is parallel to the time axis, that means the object is not moving. So these are some types of graph we have understood. Now we are going to study how to draw graphs and what is a graph paper. So this is called a graph paper. This is an image of graph paper. Here you can see. So this distance is actually 1 centimeter. So this is a 1 centimeter square box. This is a 1 centimeter square box, and each box containing 100 small boxes, where each small box, the length of the side of each small box is 1 millimeter. So this box having length 1 centimeter, and one small box having length 1 millimeter. So this is 1 millimeter square area, and this is 1 centimeter square area. So each box containing 100 small boxes. So this is a graph paper. Now how to draw graph? Let's see. Now there are some rules to draw a graph. First of all, you need to draw two axes. One is vertical and one is horizontal. Horizontal are called independent axis, and this is called dependent axis. Now always when we are plot a graph between distance and time, distance we are writing in the vertical axis and time we are writing in the horizontal axis. Second rule is we have to mention the unit. Suppose time, we can, if we consider, if the data is in minute, here you can see time is in minute, so we have to mention the unit. So here it is in minute, so minute we have to mention, and the distance unit is kilometer, we have to mention. If there is written that meter and second, we have to write meter and second. So we have to mention the units. Now this point where the uh, two axes are coinciding with each other, that point is called origin. That point is called origin, so we mark it as a O. This is also called x-axis, this is called y-axis. The vertical axis are called y-axis and the horizontal axis are called x-axis. So in the x-axis we are plotting time, and uh, y-axis we are plotting distances. Now always to draw a graph we need a data. So here is it, some datas are given, so according to that we have to draw the graph. Now students, we have to choose a suitable scale so that we can represent the large values of time and distances within this range. So here I have chosen a suitable range, like for distances it is 1 2 3 4 5 6 7. So I have chosen like that. So this is 1, this is 2, this is 3, so highest value can be accommodated within that. And the time values, the highest values is 14. So 14, that means 2 4 6 8 10 12 14. So by that way you have to do the scaling. Now after scaling you can plot the graph. So how to do that? Here you can see the first value of distance is 1 and second value of time is, first value of time is 2. So first value of distance is 1 and the first value of time is 2. So distance in 1, time is 2, so they combine in that point, so dot there, and so this is the first point. Second point, here you can see 2 and 4, so distance is 2 and time is 4. So this is the second point we got. Third point is like that. Now students, here you can see that we have drawn all the points and all the 1 2 3 4 5 6 7 points. Now what we have to do, we have to join all the points. Now here we can see, if I join all the points, it will become a straight line. So if it is become a straight line, so we can say that it is a uniform motion. So we can write that it is a uniform motion. So this graph indicates a uniform motion. Let's see the next graph. Now students, here you can see in this graph we are going to plot this data. We are going to plot the graph, distance time graph, according to this data. Now here you can see in the time and distance datas are given in second and meter respectively. So we have written here meter and second, the units. Now see, the first values are 0 0, so 0 0 point is here. Okay, next point is 2 1, that means time 2. So first we have to draw the scaling. So 0 to 12, so 0 2 4 6 8 10 12. So this is 12, and the distance, similarly we have to draw the scaling. So highest value is 36, highest value is 36. So we can divide, we can take each of the values, means each scale, how many are there, 1 2 3 4 5 6 7 8 9. So we can take 4 8, then equally we have to divide. So 4 8, then 12 16 20 24 28 32 and 36. Okay, so equally means 4 4 increment we have done. Like that way we have arranged this scale. So the first value is 0 0. So 0 0 is the, this is the first point. Second point is time 2 and distance 1. So time is 2 here, this is 2, and distance is 1. So this is 4, this is 4. So 1 will be like here. So the point is here only, the point is here. Okay, next point is 4 4. So here is 4 and 4 is here. So next point is going to here, 4 4. Next point, time is 6, time is 6, and the distance is 9. Time is 6 and distance, this is 8, up to 8, and we can consider that this is 9. So this is the fourth point. Now next point is 8, time is 8, and the distance is 16. So this is 16, this is easy, 16, and this is 8. So this is the point. Next point is 10. So this is 10 and 25. So this is 24. So 25 will be here. So this is the point of 10 25. Now the next point is 12 and 36. So 12 is here and 36 is the topmost for distance. So this is the graph. Now if we join all the points, this will not going to be a straight line. If we join all the points, here you can see this is not a straight line, it is a curved line. So we can conclude from this graph that it is a non-uniform motion. Non-uniform motion. So I hope you understand that how which one is uniform and which one is non-uniform, we can understand by the graph only. Okay, now the question is, what are the advantage and disadvantages of graph? Here you can see that the most and important advantages, there are many advantages although, but very important advantages are, first advantage is that we can easily compare the distance and time by seeing the graph. We can compare the relation between distance and time, or you can say we can easily tell about what is the type of the motion. It is uniform, it is non-uniform. So a graph is just a drawing which can show us about all the things very easily and a compact form. So this is a advantage of a graph. Another thing is we can calculate an unknown position also. Suppose that, okay, for this one you can see the distance 1, the time in for second minute the distance is 1, time in 4 minute the distance is 2. Now if we want to calculate what is the distance at 11th second, so then what we have to do, we have now this is the 11th second we can consider, because 10 and 12, so in between that this is the 11th seconds. Now we want to calculate what is the displacement or distance in 11th second. Now if we draw it, if we draw a line, that will coincide with the original graph. So at that point, what is the distance? If you see, so the distance is between 5 and 6, so we can say that the distance is 5.5 kilometer. So you can calculate the unknown distance or unknown time using the graph. So same way, from the second graph also you can calculate the unknown distances. So this is the data value. If you plot the graph, you can calculate the unknown distances. So this is another advantage. The next advantage is you can calculate the speed of the graph using a slope. How? Here you can see that if we draw a slope, suppose this is you taken, so this height is 4 kilometer, this height is 4 kilometer, so height is 4 kilometer, this is the distance. The height is 4 kilometer and the time here, time is 8, 8 minute. So if you divide, that is 0.5, isn't it? 0.5 kilometer per minute. So this will be the speed of the object. So from the graph you can also calculate the instantaneous speed of the car. That means in this point, what is the speed of the car, you can also calculate that. So these are the advantage and disadvantages of the graph. So basically there is no disadvantage, only advantages. Now let us discuss about other types of graph. So there are so many types of graph we can see here. So this first one is called, bar graph. Now here you can see the graph is looking like a column, different columns. So different columns says about different uh, datas. So this is a bar graph which is using basically in the cricket match. So here you can see one bar graph is there, another bar graph. So this is the overs. Here you can see this is the overs. This is a T20 match in the cricket. So this is first over, second over, third over, fourth, fifth, like that, 20th over. And in vertical scale it is written the runs. So first over run is about 6 runs. Second over it is about 7 runs. Third over it is about 9 runs, like that. And the red dots are wickets. So fourth over wicket falls. So this is a bar graph. So by drawing a bar graph you can uh, discuss about the score of a team. So this is called bar graph. Okay, another type of graph is called pie chart or pie graph. So here you can see in this picture there are some diet chart where the fruits, protein, vegetables, dairy and grains, other things are available. Where fruit has been colored with black, protein is ash, and vegetables with your light yellow, dairy is these things. And here you can see the percentages are given. So blue is fruit, so that means fruit you have to eat 30%. Protein is ash color, so 5% protein. Then grains is 9%, dairy is 15%, vegetable is 18%. So this, comparing to the color of this, you can also understand what is the diet chart. So this is a pie chart, and also you often see in the election time, this pie chart is using to show which team has more votes. So this is the types of graphs. So I hope you understand today's class. In this class we have understood all of the types of graph of distance and time. So you should practice these things, which is you can find these things in your book. So practice these things, and if you have any query you can contact with me. Thank you everyone for watching this video. I hope you have enjoyed that part.